In this video, I'm going to demonstrate how to solve systems of equations using substitution. And I'm going to start with a very basic example. This system is y equals 2x plus 5 and y equals 3. Those are the two equations. Now the second equation says that y equals 3. And because y equals 3, we can substitute 3 for y in this first equation and solve that. So that would look like this. We'd substitute 3 for y, and we would get the equation 3 equals 2x plus 5. We could then subtract 5 from each side, and we would get negative 2 equals 2x, and then divide by 2, and we would get x equals negative 1. And then we, of course, could check by substituting negative 1 in for x. 2 times negative 1 plus 5 is negative 2 plus 5, which equals 3y, and that's correct. Now, if the second equation is not a constant, for instance, something like this, the principle is the same. We have that y equals 7x minus 10. So instead of substituting 3 like we did last time, we can substitute this whole thing, this whole 7x minus 10 in for y and solve. So doing the substitution, we would have 7x minus 10, that's the left side of this equation, equals 2x plus 5. Then we can subtract 2x from each side, and we would get 5x minus 10 equals 5. Add 10 to each side, and we would get 5x equals 15. Divide each side by 5, and we would get x equals 3. To determine y, we allow x equal to 3, and we substitute it into the first equation to find y. So that would be y equals 2 times 3, that's a 3 that we just found, plus 5. 2 times 3 is 6, that's 6 plus 5, and that equals 11. So we have that y equals 11. And our solution is the point 3, 11. Now we can check that by substituting 3 for x and 11 for y in the second equation. And let's do that now. So we'll use y equals 7x minus 10. Let x equal 3. So this is 7 times 3 minus 10. That's 21 minus 10, and that does indeed yield 11. So that's our check. So there's the solution, and this is our check. Let's look at another example. In this example, neither equation is solved for y, but one of them has y with a coefficient of 1. So we can solve that equation for y and then solve the system. So if we take the second equation and we subtract 8x from each side, we get the equation y equals negative 8x minus 13. Now we can solve the system, and we'll write that up here. 5x minus 6y equals negative 28. And we'll use our new second equation, y equals negative 8x minus 13. We can substitute negative 8x minus 13 in for y, 6, and then solve. So we would get 5x minus 6 times, and then we substitute negative 8x minus 13. That has to equal negative 28. We'll now use the distributive property. 5x, negative 6 times negative 8x is plus 48x. Negative 6 times negative 13, that would be plus 78, equals negative 28. 5x plus 48x is 53x, and plus 78 equals negative 28. Subtract 78 from each side, and we get 53x equals negative 106. And if we divide each side by 53, x equals -2. We can now substitute x in one of the equations, and I think that the second equation would be best. So we can take 8x plus y equals -13. Substitute -2 for x. That's 8 times -2 plus y equals -13. -16 plus y equals -13. Add 16 to each side, and we get y equals 3. So our solution is x equals -2, y equals 3. We can check that in the first equation. That's 5x minus 6y. So we'll take 5x minus 6y equals -28. And we'll substitute -2 for x. 5 times -2. We'll subtract 6 times y, which equals 3. This would be -10 minus 18. That equals -28. And that checks. Let's do another example. We have one equation solved for y, so we'll substitute -2x plus 6 for y in the first equation, and we will get 4x plus 2 times -2x plus 6 equals 12. We continue solving. 4x plus 2 times -2x is -4x. 2 times 6 is 12 equals 12. 4x minus 4x is 0 plus 12 equals 12. Notice that we have 12 equals 12. And if you remember when we were solving equations, when we had a situation like this, it meant that there were an infinite number of solutions. So this means two things. If you get a 12 equals 12, this means that there are an infinite number of solutions. And it also means that solution can be specified by listing either equation, so that y equals -2x plus 6, or the other equation, 4x plus 2y equals 12, is a solution as well. Now, in this case, these two lines are exactly the same line. Two are exactly the same, and if you were to graph the two of them, they would graph right on top of each other. So this is what you look for rather, 12 equals 12, to see that the equation or the system has an infinite number of solutions. We should also note that some systems, instead of getting an equation or a result that is always true, like 12 equals 12, you might get a result like 9 equals 12, or something else that's always false. This indicates no solution. It wasn't the case here, so we'll kind of put that aside. But I don't think we need to do another example to show no solution. You just look for something like 9 equals 12, or two things that are not equal. I'd like to do one more example using substitution. In this case, neither equation is solved for y. I'm going to work through the math on this one, but understand that when you have a system where neither equation is solved for y, this probably isn't the best method, but we'll use it anyway. The way to proceed on this is to select one of the variables, and we'll select the variable x for the first one, and we'll solve for x and then substitute. Okay? I could easily have solved for y. I just picked x to use a different variable this time. So we start with 5x minus 6y equals 60. Add 6y to both sides, and we get 5x equals 6y plus 60. And divide both sides by 5, and we get x equals 6/5 y plus 12. We can take this and substitute that into the second equation for x, and we would get 6 times 6/5 y rather, plus 12 minus 5y equals 61. Let's continue solving. 6 times 6/5 is 36/5 y. 6 times 12 is 72 minus 5y equals 61. I'm going to subtract 72 from each side. And we'll get 11 here, negative, and 36/5 y minus 5y. Okay. 36/5 minus 5, well, 5 is 25/5, so 36/5 minus 5/5 y is going to be 11/5 y, and that will equal negative 11. If I multiply each side by 5/11, I will get that y equals negative 5. With y equal to negative 5, I can substitute that into one of the equations, and again, I'll choose the first one, and we'll solve that. So we'll take 5x minus 6y equals 60, and we'll substitute negative 5 for y, so this will be 5x minus 6 times negative 5 equals 60. 5x minus 30, or plus 30 rather, equals 60. 5x equals 30. I subtracted 30 from each side, divide each side by 5, and I get x equals 6. So our solution is 6, negative 5. We check this in the second equation. We can use 6x minus 5y equals 61. X is 6, so this will be 6 times 6 minus 5 times negative 5. That will be 36 plus 25, and that indeed equals 61. So we have checked. So there's our solution. Again, it's not the best method, but if you have no other method, this is the way you got to do it. Okay, and that ends the video.